dear students, now next topic, that is circular motion. Now we know this thing, if any object having mass m is moving with velocity v on the circular path, then its acceleration, that is v square by r, and that acceleration is towards the center. So that is the centripetal acceleration, right? Now if for any object we want to sustain the circular motion, then as per Newton's second law of motion, we must provide the centripetal force that is equal to mv square by r. So if this much force is provided to the object, then its circular motion that will be sustained, okay? And this force that should be towards the center, therefore it is known as a centripetal force. Now let's think about the motion of a car on the level curved road, right? Now suppose a car having mass m that is moving on the curved path, and that curved path, that is the level path. Here the radius of the curvature, that is r. So if it is moving with speed equal to v on this curved path, its centripetal force that will be v square by r. It implies that to sustain its motion, the required centripetal force that will be mv square by r. Now here, how many forces are acting? Say, one force, that is weight of the car, that is mg, which is in downward direction. Second force, that is the normal reaction, right? That is by the road on the vehicle, that is vertically upward. And the frictional force, which is parallel to the surface towards the center between car tire and road. Clear? Now see here. Since there is no vertical acceleration, or in other words we can say there is vertical equilibrium of the car, therefore n and mg are perfectly balanced. So we can write n minus mg equal to 0 or n equal to mg. Now see here, we must provide the centripetal force, and that is equal to mv square by r. So which force is towards the center? The friction between tire and road parallel to the surface towards the center will provide the required centripetal force mv square by r. So we can say centripetal force will be provided by static friction, that is mv square by r, right? Now here, this required centripetal force, that should be less than Fs maximum, because see here, if we increase the speed v, then required centripetal force increases. No doubt, here friction also increases, but friction have certain limit. It can increase up to Fs maximum, which is equal to mu s into n, but n equal to mg. So we can say Fs maximum can be increased up to mu s into mg, where mu s, that is the coefficient of static friction between tire and road. It implies that, see here, frictional force can't be increased from this value. So our required centripetal force to sustain the motion of the vehicle on that curved level road, that should be less than or equal to Fs maximum, right? Or we can say that should be equal to less than or equal to mu s mg, okay? Now here, if mv square by r is less than or equal to mu s mg, then vehicle can move safely on the road. Suppose here velocity increases, then this required force, right, means friction maximum provide this much force. If your required force is greater than this one, who will provide it? So now in that particular case, your vehicle will slip off from the road, right? So here we can write M cancel. If we take R on this side, then V square, that should be less than or equal to RMG. So V maximum, that should be equal to under root mu s RG. And this V maximum, that we can say that is the maximum safe speed of the vehicle on that particular given curved road. If your velocity is greater than this one, then definitely the vehicle that will slip off from the road. See here, very important thing that you can observe in this equation of the maximum safe speed for the motion of the vehicle on the curved level road. In that, mass of the vehicle is not appearing. It implies that this one is true for any type of vehicle. For the given curved level road, the maximum safe speed that is same for bicycle, scooter, motorbike, car or truck, any vehicle. Here, if move on that road with a speed greater than this V maximum, then definitely it will slip off in outward direction. Clear to all of you?